Okay, so the question's on page 144, starting with number 5. It says, a friend pushes a 600-gram textbook along a lab bench at a constant velocity. Okay, so it's 600 grams, which of course we'll have to change to kilograms. This is Fg, this is Fn. It says they push it. Constant velocity with a force of 3.5 newtons. Determine the normal force. Oh, and I'm assuming there's going to be friction here. Okay, so constant velocity means AX is 0 meters per second. Determine the normal force. So we do sum of the forces in the y direction. And the textbook isn't moving in the y direction, so this goes to 0. So we have Fn and we have Fg. Fn is going up, Fg is going down, so let's call down negative. So Fn equals Fg equals mg. So Fn equals 600 grams is 0.6 kilograms times 9.81 meters per second squared. And so that will give us an Fn of 5.886 newtons for part A. Part B says calculate the force of friction and the coefficient of friction. So to get the force of friction, we can do the sum of the forces in the x direction. So sum of the forces in the x direction. And the question said he pushes it at constant speed, so that means AX is 0. So in the x direction, we have F going one way and friction going the other. So it's going to be F minus friction equals 0. So F is going to equal friction, and the question told us F was 3.5 newtons. So that means friction is 3.5 newtons. And then the coefficient we would find from FFR equals mu Fn. So mu is equal to friction divided by the normal force. So 3.5 newtons divided by 5.886 newtons. And you get a mu of 0.5946. Part B. Part C says, which coefficient of friction have you found, static or kinetic? And it says that you're pushing at a constant velocity, so it has to be kinetic, because if it's moving, it's kinetic. If it was stationary, it would be static. Number 6. A 125 kilogram crate, so 125 kgs, full of produce is slid across a barn floor. What is the normal force? So we have Fg going down, we have Fn, that's really an arrow, I promise, going up. So sum of the forces in the y equals may, so Fn minus Fg equals 0. So Fn equals Fg equals mg. So Fn equals 125 kilograms times 9.81 meters per second squared. And when you do the math, you get an Fn of 1,226.25 newtons. Part A. Part B says, calculate the minimum force required to start the crate moving if the coefficient of static friction is 0.43. Okay, so what is if the coefficient of static friction is 0.3, sorry, just trying to figure out where I am here, that's part A. Part B, coefficient of static friction is 0.3, so we get 43, so we can find our frictional force. FFR is equal to mu Fn. So FFR is equal to 0.43 times this 1226.25 newtons. So friction would be equal to 527.2875 newtons. Okay, so this is our frictional force, but then it wants to know how much force would you have to push with to start the crate to move. So if the maximum frictional force going back is this 527.2875, then you're going to need to push forward with the same force. So this frictional force that you just found is the force you need to push with, 527.2875 newtons, to start it to move. Remember, you have to be able to match the maximum static friction. C says, calculate the minimum force required to start the crate moving if half of the mass is removed. Well, if we take half of the mass out, then the normal force will be half. And if the normal force is half, then friction is half. And so the force that you'd have to push with would be half. So it's going to be half of 527. So what is that? 263.64375? Or something like that. I think that's what I think what I said was right. So you just have to take half of everything. So if you've shown your workout like that, you don't actually have to redo anything. You can just say half the original F, which was 263.64375 newtons. All right, number 7. Number 7 says, avalanches often result when the top layer of snowpack behaves like a piece of glass and begins to slide over the underneath layer. Calculate the force of static friction between two layers of horizontal ice on the top of Mount Everest. If the top layer has a mass of, okay, so the top layer has a mass of 200 kilograms. And it's ice on ice. And you can find, so this is the force we're going to push with. This is Fg, this is Fn, and this is friction going back. And you need to go to the chart, the table, to find out that the coefficient of friction between ice on ice is 0.1. It's also at the top of Mount Everest. So you need to be careful here because the acceleration due to gravity is not 9.81. It is 9.7647. So little g is 9.7647 meters per second squared. And the question wants to know, calculate the force of static friction. So first you need to do sum of the forces in the y direction to find your Fn. So it's going to be Fn minus Fg equals 0. So Fn equals Fg equals mg. So Fn equals your 200 newtons times 9.7647 meters per second squared. So Fn should equal, move the decimal 2 places, 1952.94, I believe, newtons. Okay, and then it wants to know what will the frictional force be. So FFR is equal to mu Fn. And if you looked up on the chart, ice on ice, it's 0.1 times the 1952.94 newtons. So friction should be 195.294 newtons. Number 7, done. Number 8. Number 8 is, turn this around, is a book that you're holding against the wall. And you're pushing in with some force, and the normal force is pushing out. So it says that you're pushing with 63 newtons. And it says the book is 2.2 kilograms. And it wants to know what will be the coefficient of friction. Acting down will be Fg, and the force acting upward is friction. So this time, because we always want Fn first, start with some of the forces in the x direction. Because this time Fn's going this way. So it'll be Fn minus the F you're pushing with is equal to, it's not moving in the x direction, 0. So Fn will equal 63 newtons. Go to some of the forces in the y direction, and it's not slipping, so it has to be 0. So it'll be friction minus Fg is equal to 0.